Boosting brain health through cellular energy and nutrition. Introduction. Your brain is one of the most energy-demanding organs in your body, consuming nearly 20% of the body's total energy supply. When cellular energy production declines, it affects not only physical energy but also cognitive function, emotional resilience, and mental clarity. Recent research highlights the crucial link between mitochondrial energy production and brain health. Poor diet, oxidative stress, and environmental factors can impair this delicate balance, contributing to cognitive decline, mood disorders, and fatigue. Understanding how to optimize cellular energy through nutrition and lifestyle can provide a powerful strategy for maintaining mental and emotional well-being. Cellular energy and brain function, the missing link. Cellular energy is produced in the mitochondria, tiny powerhouses within cells that generate adenosine triphosphate, ATP, the energy currency required for everything from muscle movement to brain processing. When mitochondrial function is impaired, the brain lacks the energy it needs to maintain optimal performance. Reduced mitochondrial efficiency is associated with depression, anxiety, cognitive decline, and even neurodegenerative diseases. Studies show that when cellular energy production decreases, the brain prioritizes survival by limiting higher-order functions, resulting in brain fog, irritability, and impaired focus. To support brain health, enhancing mitochondrial function through diet, sunlight exposure, and supplementation becomes essential. The role of linoleic acid in impaired brain function. One of the greatest threats to cellular energy production and brain function is the excessive consumption of linoleic acid, LA, an omega-6 fatty acid found abundantly in seed oils and processed foods. While some omega-6 fatty acids are necessary for health, excessive LA consumption contributes to oxidative stress. LA is highly prone to oxidation, leading to the formation of harmful byproducts like 4-HNE, 4-hydroxynonenal, that damage cell membranes, proteins, and DNA. Mitochondrial dysfunction. Oxidative stress impairs mitochondrial function, reducing ATP production and compromising cognitive function. Neuroinflammation. Chronic inflammation fueled by LA disrupts neuronal signaling, contributing to anxiety, depression, and cognitive decline. A diet high in processed foods, vegetable oils, and fried foods exposes the brain to oxidative stress and toxic metabolites, which impair brain function over time. Reducing LA intake by minimizing processed foods and using healthier fats, such as olive oil, coconut oil, and grass-fed butter, can protect mitochondrial health and enhance cognitive resilience. Sunlight, a natural brain booster. Sunlight is a powerful yet often overlooked ally in maintaining brain health. Exposure to sunlight, especially near-infrared (NIR) radiation, has a direct impact on mitochondrial energy production. Near-infrared light penetrates deep into tissues, stimulating cytochrome C oxidase, a key enzyme in the mitochondrial electron transport chain. This process enhances ATP production, reducing oxidative stress and inflammation. Additionally, vitamin D synthesis triggered by sunlight exposure plays a critical role in regulating mood, immune function, and neuroprotection. Low vitamin D levels have been linked to an increased risk of depression, cognitive decline, and Alzheimer's disease. Studies suggest that maintaining optimal vitamin D levels not only supports brain health, but also reduces inflammation, protecting the brain from oxidative stress. Practical tips for sun exposure. Aim for 15 to 20 minutes of sunlight exposure daily, focusing on the largest surface area of your skin. Expose your body to sunlight during midday for maximum vitamin D synthesis. Use caution to avoid excessive sun exposure, but prioritize regular, sensible sun exposure to boost mitochondrial function and overall well-being. The importance of glucose for brain health. Contrary to popular low-carb diet trends, glucose is a critical fuel source for the brain. While the brain can utilize ketones in periods of fasting or low carbohydrate intake, glucose remains the brain's preferred and most efficient energy source. Insufficient glucose availability can impair cognitive function, mood stability, and decision-making. Research highlights that depriving the brain of glucose, as seen in extreme ketogenic diets or prolonged fasting, can result in increased cortisol production. Low glucose levels trigger stress hormones, increasing anxiety and disrupting mood. Reduced neurotransmitter synthesis. Glucose is essential for producing neurotransmitters like serotonin and dopamine, critical for emotional balance. Impaired memory and focus. Low glucose levels reduce synaptic plasticity, affecting learning, focus, and memory. A balanced approach that includes moderate carbohydrate intake, preferably from whole, nutrient-dense sources such as fruits, vegetables, and root vegetables, supports cognitive performance and emotional stability. Glycine and choline, nutrients for optimal brain function. 1. Glycine for sleep and neurological health. Glycine, an amino acid found abundantly in collagen and bone broth, supports brain function by reducing neuronal excitability and promoting relaxation. Studies have shown that glycine supplementation improves sleep quality, cognitive function, and emotional regulation by enhancing inhibitory neurotransmitter activity. Glycine promotes restorative sleep by lowering core body temperature and enhancing REM sleep. It reduces neuronal excitability, which helps calm the nervous system and alleviate anxiety. Glycine plays a role in glutathione production, a critical antioxidant that protects brain cells from oxidative stress. 2. Choline, the building block for brain communication. Choline, primarily found in egg yolks, liver, and grass-fed meats, is a precursor to acetylcholine, a neurotransmitter essential for memory, learning, and parasympathetic nervous system activation. Adequate choline intake ensures improved cognitive function. Higher choline levels are associated with better memory and learning capacity. Enhanced nervous system function. Acetylcholine regulates the parasympathetic nervous system, promoting relaxation and balance. Protection against cognitive decline. Choline deficiency has been linked to increased risk of neurodegenerative diseases, including Alzheimer's disease. Incorporating glycine-rich foods and choline sources into your diet supports brain health, cognitive performance, and emotional balance. Conclusion: maintaining brain health requires a multifaceted approach that includes optimizing mitochondrial energy production, reducing oxidative stress from linoleic acid, ensuring adequate glucose intake, and incorporating key nutrients such as glycine and choline. Sunlight exposure, nutrient-dense foods, and reducing processed food consumption can have a profound impact on mental and emotional resilience. By addressing both mitochondrial and neurological health, individuals can boost cognitive function, improve mood, and protect against age-related cognitive decline.